Welcome students. Today we will discuss about the back price problem using Tabu Search Algorithm. That means how to solve the back price problem using Tabu Search Algorithm. So back price problem is an integer optimization task in which we need to find the best values for selling prices for 5 different bags. And the formula for objective function is given here. The difference between the overall sales minus the production cost. Okay, and the implementation for this back price problem, or the implementation for computing the back price problem, is already given here in the previous videos. So we'll try to copy that. Okay. So it's all about finding the best selling price values for 5 different bags. So here the dimension is 5. Okay, and the formula for computation of the overall production cost and overall sales is given in this formula. So I want you to understand. Okay, so the range of selling prices is in between $1 to $1,000. Okay. So let us see the syntax for Tabu Search Algorithm. The syntax for the Tabu Search Algorithm is this one. Tabu Search, it accepts some input arguments. Let us see one by one. So this Tabu Search Algorithm is also similar to hill climbing algorithm, and the main difference between hill climbing and Tabu Search is the maintenance of memory in the Tabu Search. So the main purpose for maintaining the memory is to avoid the most recent solutions. Okay, that means the recent solutions are stored in the memory. When you are generating a new solutions, care is taken that you can avoid those most recent solutions. So that is the reason for memory in Tabu Search. In that way, we may find out the optimum solution. Okay, that is the logic behind. So let us see the Tabu Search. So the first argument is the size. So here you can see you have to specify the number of the length of the binary solutions. So again you need to understand that this function, it operates on binary values. Okay, this function, this optimization algorithm, this function, it operates on binary values. So actually our back price problem is about integer. Okay, so integer values between 1 to 1000. So what you have to do is, for each selling price you have to represent in binary form. Okay, that is the one you have to understand. So you have to specify the size of the binary solution. And the second argument is iteration. So how many iterations the Tabu Search algorithm should run. Okay, and then the third argument is, you can see objective function. This is our profit function in our case, which we have to implement. Okay, and then the config. So this parameter is the initial solution. That means from where the algorithm has to start. So generally we will put all zeros from origin. You can start the solution. So this you have to initialize as, and then you have to specify the neighbor. How many neighbors has to be generated for each iterations. So if a neighbor is equal to 4 means for each intermediate solution or candidate solution, 4 neighbors are generated. Out of 4 neighbors, best one is selected. Okay, that is a logic. And finally this list size. This is the difference. Okay, compared to hill climbing algorithm, here list size represents the memory. So we have to specify the number. So how many number of solutions, recent solutions, has to be stored. If we specify list is equal to 10 means this list size, the memory will store 10 recent solutions. Okay, so that is the logic behind. You have to specify the memory size here. So once you understand the basic arguments, now let us see how we can solve the back trace problem using Tabu Search algorithm. So this Tabu Search algorithm is present in this library. Better you need to install it before the application, before the program. And similarly here we have used the library GA, genetic algorithm. Why? Because we are using one package, one function called, you can see this function. Where is that function? This one. Binary to decimal. This function we are using actually in our code. That is the reason we are using this package. Okay. So apart from that, we are not using still genetic algorithm in this. Only we are using library Tabu Search. Okay. So let us one by one. So this code we have discussed n number of times in the previous videos. This is the function, implementation function for the profit function, objective function. So this is a profit function for our back price problem. The entire implementation is already discussed in our previous videos. So the same thing I have copied here. And then the next thing is Tabu Search. One by one we will see. So please see this. The first one we have to understand that for this problem we have to find the selling price for 5 bags. So the dimension, number of variables is 5. Okay, each variable is an integer. So but our algorithm accepts only the bits. So first argument is size in terms of length of bits. So what you have to do is find out what is the maximum price. 1 to 1000. So 1000 is a maximum price. For representing 1000, how many bits you require? How many bits? If you say 10, then it is correct. Okay. So 2 power 10 means if you have 10 bits, you can store up to 1024 values. So the formula for finding the number of bits required to store the maximum value is given here. So it is just a log function applied to the maximum value to the base 2, and then we applied the ceiling function. So once you got it, you will understand that for representing 1000 you need 10 bits. Okay. For representing 1000 you need 10 bits. Similarly, here we are having 5 different bags. So for each bag here you should use 10 bits. So total how many number of bits? 10 plus 10 plus 10 plus 10. So therefore it is 50. Okay. 5 into 10. So total 50 bits. That is a overall size number of bits you required. Okay. So 50 bits you required. So size is 50. In this application it is 50. And the next thing is, what is the next argument? Iterations. Iterations you can give directly as 100. I want 100 iterations. And after that, initial solution. You can see config. This parameter represents the initial solution from where we have to start. So you can take some random value, okay, and assign it as yes. Okay, some random value. You can start from origin also. Some random value you initialize of size 50. Okay, so randomly you take 50 size bits. Okay, that is the first thing you need. And after that, we have to define, we have to call the function. Okay, Tabu Search Algorithm. Okay, Tabu Search Algorithm. So size we have defined, we have specified the iterations directly and the profit. Now the thing is, if you see in our previous algorithm, this profit function actually it is designed for computing integer values. So actually you can see this x is a vector of integer values. So here the computation will be like that. But our algorithm throws only the binary values only. So what you have to do is you have to convert. You should convert. So here what we will do is we will define another function P profit function, because that is you are going to pass here. We cannot directly pass this function. Why? Because a Tabu search algorithm, it operates on, it will throw only binary values. Okay, so there should be conversion, it should be there. For that purpose we are using this code. This should be passed to here. You cannot directly pass the integer profit function. So binary profit function, B profit, binary profit function, X will have a strings of zeros and ones, and that will be converted into that. This function, the job of this function is this one. You can see this. The job of this function is it accepts a strings of ones and zeros and converts into vector of integer values. Okay, vector of integer values. Vector of integer values. So that is a function here. Here the logic is very simple thing. If you want, the logic of this function is very simple thing. We have implemented. So if you are having 1 0 1 0 1, here you are having bits like this. So I want to divide these bits in terms of 4 means. You can see this. So what I will do is, so I will take first 4 bits. It is a strings of ones and zeros. I will take it and I will divide the chunk into multiple values. So the next 4 like this, and then finally so the corresponding integer value for the first 4 bits is 8421. This is 10, 12, 13, 12. So this string values, it gets converted into a vector of 10, 13, 12. Okay, it gets converted into vector. If you give the strings of 1 zeros, it will be converted into integer, vector of integer values. That is the purpose of this function. Okay, please see through this. So when strings of zeros and ones are generated, so obviously it can, the integer value may exceed the maximum price. Okay, because when generating, you can generate up to 1024 values. Since the number of bits is 10, you can generate maximum of 1024. So if it exceeds the maximum price, you can put the corresponding the value as minus infinity. So if it is within the maximum price limit, you assign this value and throw it. That's it. So the only thing we have done is this Tabu search algorithm throws a strings of binary zeros and ones. So you need to convert into the vector of integer values. For that purpose, we are using this function, and then we are calling this profit function. Once it is converted into integer values, you can call this function. Okay, that's what we are doing here. So after calling this, you will get the value. So and finally the configure, so which we have initial solution, and we set neighbor is equal to 4. This is how many neighboring solutions has to be considered. Actually in this application they told to take neighboring is equal to 4 and the number of iterations as 200. Number of iterations, where is the number of iterations? This is the 200, and neighbor is a 4, neighbor is 4, that's it, correct. So everything is okay. Okay, here the dimensionality they told, I think they asked the dimension value as 8. Actually this is wrong. Actually the dimension is 5. In our problem only 5 bags are there. So So it is not necessary. So once we set it, the Tabu search algorithm will throw a output list object. Okay, so you can see the list object, the output list, it contains the elements, two elements, config keep element and e utility keep element. This is a matrix with stored solutions, and similarly this is a vector of evaluated values. Okay, so once you understand it, that's it. So you can use this function to print out. Let us execute. You select it and you run it. That's it. So 200 iterations it is run. So you can see the best value is, you can see best value is this one. $401. The selling price of best value is 401, and best value of second bag is 377. Best value for third bag 374, like this. This is the optimum price we are getting. It is a deterministic algorithm, so you need to understand. So, so we have defined the list size 16. That means most recent 16 solutions are stored in this memory. Okay, once it is stored, you will not generate the recent solutions again. That is a logic, and for taking the best solutions, we will compare with 4 neighboring solutions. Okay, to choose the best one, we will compare with 4 neighboring solutions. Okay, so this is how the algorithm will execute and we will get the output. So the only thing we are doing is this one. Why? Because we have to convert binary into integer values. So because a Tabu search, it is performing the operations on binary variables. Okay, that is the reason. So in fact it will give you only the binary values only output. Again, to get meaningful correct output, we have to use this function, binary conversion from binary to D prices. So we have used it here for 15. So with this I want to finish. Thank you, students.